the heart. Although the size of a fist, but it's very complex in structure and function, which is not comprehensible by everybody, except for medical specialists. So what if people who do not belong to the medical field want to understand the function of the heart to add to the medical field? How do they understand this? There is an easy and quick way, and that is the functional block diagram approach. The functional block diagram utilizes rectangles to indicate various compartments within the heart, diodes to indicate one-way flow that represent the valves within the heart, and the wires are used to indicate the blood vessels, veins, and arteries, and the resistance here just indicates the hindrance that the blood faces while flowing. So now let's combine this into a functional block diagram to represent the blood flow through the body and the heart. So starting from the top, let's start from the aorta that carries the oxygenated blood to various organs of the body known as the systemic circulation. After the body gets nutrients through the blood and the oxygenated blood, now the organs and the cells give up deoxygenated blood. So this deoxygenated blood from the top of the body or from the upper portion of the body is collected by the superior vena cava, and from the lower part of the body is connected by the inferior vena cava. The superior and inferior vena cava come into the right atrium with the deoxygenated blood. From the right atrium, blood flowing through the tricuspid or the right atrioventricular valve flow into the right ventricle. From the right ventricle, passing on from the pulmonary valve, the blood flows through the pulmonary artery. Now here, in the pulmonary artery, the blood is deoxygenated. So what we usually know is arteries carry oxygenated blood and veins carry deoxygenated blood. But this is the opposite for pulmonary artery and veins. Those are associated with the lungs. So pulmonary is a medical term for any activity associated with the lungs. So the pulmonary artery brings deoxygenated blood into the lungs. In the lungs, the blood gets oxygenated and flowing through the pulmonary vein flows into the left atrium, and from the left atrium, it passes in a one-way direction through the diode that represents the mitral or bicuspid valve or the left atrioventricular valve and passes into the left ventricle. From the left ventricle, the blood passes into the aortic valve and flowing into the aorta repeats the systemic circulation throughout the body and collects the deoxygenated blood again from the superior and through the superior and inferior vena cava into the right atrium and repeats the whole process again. So this circulation is associated with the whole of the body. Now there is another circulation that needs to be mentioned separately. That is the coronary circulation, the circulation through the heart. Now, just above the aortic valve at the root of the aorta, the right and left coronary arteries originate. The right coronary artery has a shorter path than the left coronary artery. These two branches further subdivide and course over the surface of the heart, known as the epicardium, and supply blood and nutrients to the heart. And therefore, this circulation to the heart is referred to as epicardial coronary circulation, and the vessels are referred to as epicardial coronary vessels. Then, the deoxygenated blood from both sides of the heart accumulate in the coronary sinus, which brings the blood to the right atrium, the deoxygenated chamber, the chamber of the heart that has the deoxygenated blood. From the right atrium, in a similar fashion that was explained previously, the deoxygenated blood comes into the right ventricle, and so on. Now, while flowing the blood through the right coronary artery and the left coronary artery, experience resistance through the ventricles and the atriums. These are indicated by the resistance showed here. Now, here the pumps are in series, so pumps in series exhibit the same flow. Now, there are special cases when the flow in the left part and right part are not the same. So, when the flow in the right side is higher than the flow in the left side, then volume and pressure increase in the pulmonary system, causing pulmonary edema or fluid buildup in the lungs. When the left side flow is higher than the right side flow, then volume and pressure will increase in the systemic circulation, resulting edema in the tissues. So this is the blood flow through the body, through the heart. That is the cardiac blood flow explained in a simple way. Thank you.